So basically what we're showing here is a couple of things. One is something that's kind of obvious and interesting, and the second, underneath it all, is something that is actually pretty astounding. And the first thing is what we're showing here is a mirror Mezz cable running at a 0.5 meter at 112 gigabits. The reason that's important is a couple of things. The application for that alone is something that can run at 112 gigabits, point to point within printed circuit boards, anywhere going ASIC to ASIC as an example. And we can scale this to make these very large for conducting point-to-point things within systems with very large amounts of contacts. Second thing though is it's a very, very low loss interconnect that we will use for other products like bypass to make sure that we can have a low cost alternative or product that will go from the ASIC to the front panel I/O. So this will end up being a fundamental part of bypass. But the real important part and what's hidden here is the termination technology. It's called TGA. It's a brand new method of terminating copper interconnects here at Molex that essentially what it does is approximates a waveguide. So for all practical purpose, that termination is invisible. Meaning if we look at the performance of this cable and we look at the performance of the connector, and the cable assembly itself has basically the exact same performance. And what that is for us is that's a fundamental technology going forward. Because not only does it allow us to make significant improvements to all kinds of cables, but really importantly and interestingly is as we move from 112 to 224, obviously it's early to talk about, but from our perspective, this is a first proof of concept of something that is a termination technology that shows us a path to 224. So there's three fundamental reasons why we're incorporating TGA and why we view this as so strategic. First of all is it allows us to eliminate a big component of loss. So it's an ultra low loss system. The second reason, and part of that, is it allows us to create these super low profile interconnects, which are going to be important as we get underneath the heatsink and even onto the ASIC to eliminate losses. Then the third component, and the interesting part, is as we move from 112 to 224, and I know it's a little scary to talk about that at this point, but we know that fundamentally if you're going to go to 224, that the basic construction of interconnects today breaks down. And what TGA does is this is the first built, functional, tried out system that allows us to work a termination method that works as a waveguide. And we know now that we have a path that tells us there's a possibility of success here at 224. And that is probably one of the more exciting perspectives from a strategic long-term point of view, in addition to all the advantages of ultra low profile, ultra low loss, enabling to get right next to and indeed on the ASIC today at 112.